Welcome to Hello World program in Rust. A Hello World program prints the text Hello World to the screen. Since it's a very simple program, it's often used as a first program to learn a new programming language. So let us print text Hello World on the screen. First, understand how we can write this program in Rust. So you have to use a main function, and inside the main function you're making use of println to display hello world on the output screen. So let's discuss in detail about it. First, the main function. This is the main function which is acting as an entry point of every Rust program. It is always the first code that will run the every Rust program. The body of the function is wrapped inside this curly brackets. You can see here. Now, inside this main function, we use println macro in order to print the text to the screen. This hello world string is considered as an argument to the println. Finally, we have to end this line with a semicolon, which indicates the expression is completed. In this video, I'll show you how to work with Rust programming online. So very simple, just open Google and type online Rust playground and press enter, or just click on Google search and you will get very first link, that is Rust playground. Click on it and you will see like this. And if you want, you can also configure. Suppose if you like light colors, okay, then set theme to light color. Suppose if you like dark colors, then go for dark color, okay. And you can also press Ctrl plus to increase or zoom, okay. So you can see here already there is an example function main, and inside which there is a statement or a macro to display hello world. So if you click on this run button, you will be able to see the output, that is hello world, okay. So suppose if I modify this to welcome to Rust programming class, okay, and just run this code and see the result. You can see the same result. So we are going to use this particular IDE throughout our course, okay, and it's pretty simple. In this video, we'll discuss about comment lines in Rust programming. So what is the purpose of using comments? Whenever you want to explain some part of the code, then you can immediately use comment lines. And these comments are completely ignored and are not evaluated during the code execution. So ideally, a comment should allow the reader to understand the program. So you can observe in this example, main function is clearly explained with the help of a comment line, saying that it is an entry point of the program. And later there is a println statement, and again this is explained with the help of a comment line, and it says println is basically used to display the text on the screen. Now coming to what are different types of comments. One is line comment, the other one is block comment. You can observe whenever you want to write a line comment, you have to use two forward slashes and followed by the comment line. And whenever you are writing a block comment, this block comment must be enclosed between slash star and star slash. So look at this example of a line comment in Rust. Here, declare a variable is the line comment, and this comment is going to extend up to the end of the line and is also known as the single line comment. And here it clearly explains we are trying to declare a variable called x in the subsequent line. Now consider block comment in Rust. So here again declare a variable and assign value to it. This is the block comment as it is enclosed in between slash star and star slash. You can see this block comment extending for multiple lines. Hence it is also known as multi-line comment. In this video, we'll discuss about variables in Rust. So in any programming language, generally variables are used to store the data. So physically, we can consider as a memory location, and logically, we can call it as a variable. So let us consider an example of how to define a variable in Rust programming. So in this example, x is the variable which is storing 1. So you can say let x equal to 1 semicolon. Here x is a variable and it is currently storing a value of 1 inside it. Okay. Now in this example we have created two different variables. One is age, the other one is name. You can see here let age is equal to 31. So here age is a variable which is used to store an integer value, and similarly you can consider there is one more variable called name, but this name is used to store a string here. Okay, and finally we have used the macro called println in order to print the variables. Okay, so there are two print statements. You can see here one print statement is used to print the variable value of age. The other print statement is used to print the variable value of name. And by default, the Rust variables are immutable, which means we cannot change the value of the variable once it is defined. So let us consider an example for this. So when we run this particular code, so you can see this particular code, when we run, we will encounter an error. This is because we are trying to change the value of the x variable from 1 to 2. So you can see here let x equal to 1, and later we are changing the value of the variable x to 2. So this is going to cause an error because Rust allows us to create mutable variables, but here we are not creating any mutable variables, as by default these variables are immutable. So currently x is a variable which is immutable. The moment you try to change the value of x, immediately it will produce an error just like this. Now we can use mute keyword before the variable name in order to create a mutable variable. So in this example, x is a mutable variable. Now we can change the value of x. Suppose if you start writing x is equal to 2, this will work for this example because in this example we are carefully writing x is a mutable variable. So let's see an example here. So let mute x equal to 1, which represents x is a mutable variable. So we can change the value of the x variable here. See, the moment you write x equal to 2, you can see we have successfully changed the value of x variable. This is because we have defined x variable using mute keyword. So this is the corresponding output here. We are able to print value of x equal to 1, and also after updating value of x to 2, the same value is getting reflected. Okay, like this. In this video, we'll discuss about what are different data types in Rust. So there are four primary data types in Rust, and they are also known as the scalar types. First one is integer type, second one is floating point types, third one is Boolean data type, and fourth one is character type. So let us first focus on integer type. In Rust, we use integer types to store whole numbers, and this integer type is again divided into two types. One is signed integer type, the other one is unsigned integer type. So let us focus on signed integer type. Here in this example, we have created the number variable of type I32, I representing integer type, which is a signed integer type representation, and it is storing a value of 100. Now, if you clearly focus on integer type I32, it has got two parts into it. I is representing signed integer type, which can store both positive and negative values. 32 is representing size of the data type, which means how many bits it is going to take or occupy in the memory. Since it is 32, it takes 32 bits of space in the memory. So let us consider this example. Here we have defined two integers x and y, and both x and y are of signed integer types, each occupying 32 bits. And x is assigned a value of -100, whereas y is assigned a value of +100. Now the same thing we are displaying in the output screen with the help of println macro. Let us focus on unsigned integer type. Here we have created the number variable of type U32. U is representing unsigned integer type, and the 32 is specifying the size of the data type. Okay, so it is going to take 32 bits of space in the memory, and the value that is stored inside this variable number is 50. So let us see this example. So here x is a variable of type unsigned integer type. Since we are using U32 to represent the variable x, here x is going to occupy 32 bits, and it is capable of storing unsigned values. Okay, because U representing unsigned integer type. So in this example, it is storing a value of 50 inside it, and the same value will be displayed as output. Okay. Now the problem arises when you try to store a negative value inside an unsigned integer type variable. So look at this example. Here x is a unsigned integer type, and you are trying to store -50 inside it. See, clearly -50 is representing a negative value. You cannot store a negative value inside an unsigned integer type variable. If we try to store negative numbers to U32 type variables, we will get an error. Now let's see what are different categories of integer data types in Rust. So first, 8-bit size. Again, how do you represent 8-bit? For signed, it should be I8. For unsigned, it should be U8. Similarly, if you want to use a 16-bit size, then the signed representation should be I16. And unsigned representation of the data type should be U16. And so on like this. You can see we have already worked with 32-bit. Similarly, for 64-bit, you have to write I64 for signed, U64 for unsigned, and finally 128-bit signed representation should be I128 and unsigned should be U128. So depending on the size of the data, we can classify the signed and unsigned integer type like this. Now let us consider floating point type. Here the floating point types are used to store fractional numbers. So basically the numbers with decimal points. In Rust, floating point data can be divided into two types. Here F character represents floating point number. 32 and 64 will be representing the size in bits. You can see float is clearly classified into two types, F32 and F64. So in both these cases, F is indicating a floating point number, and here in the first case 32 is representing 32-bit size, and in the second case 64 is indicating 64-bit size. Now consider this example. Here we have used two variables, one is x, the other one is y. X is considered as F32 type, which means F32 is a single precision floating point type, whereas y is considered under F64 type, which means F64 is a double precision type. So clearly with a double precision like F64, you can store data with a larger decimal range. Okay, and you can consider F64 to be more precise compared to F32. So in this case, you can see X is a variable under F32 type and you are storing 1.73, whereas Y is under F64 type and you are storing 12.754891. So clearly double precision is going to store the data with a larger decimal range. In Rust programming, we can make use of Boolean data type, and it will take two possible values, true or false. Okay. So whenever you declare a variable under Boolean data type, the value of the variable should be either true or false. That's it. So let's see this example. In this example, we have used bool keyword in order to represent the Boolean type in Rust. So there are two variables taken. One is flag1, the other one is flag2. Flag1 value is assigned as true, whereas flag2 value is assigned as false. Now look at this example. When you try to print flag1 value and flag2 value, so they should be able to print their corresponding values because flag1 is already initialized to true and flag2 is already initialized to false. So the output should be flag1 equal to true and flag2 is equal to false. Now consider character type. So here char represents the character type variable and we have to use single quotes to represent a character. So in this example, you can see variable name is character and it is storing Z, which is a character specified inside single quotes. Now look at this example. We can also store the special characters like dollar symbol, @ symbol, ampersand symbol, etc. So in this example, I'm storing a @ symbol as a special character. So the name of the variable is SPL underscore character and the data type is defined as char type and the value assigned to it is @ symbol enclosed in single quotes. Now when you try to print the same value, that is SPL underscore character, you will be able to see @ symbol which is stored inside it. Okay. In this video, I'll explain an example for assignment operator in Rust. So many times we often use this assignment operation. Let us suppose if you want to basically assign some value like x equal to 100, Here equal to operation is nothing but assignment operation, right? So the value of x becomes 100 because 100 is assigned to x with the help of assignment operator. Okay. Now when I print this value, I'm able to access it. Okay. Simply I'll write value of x is. Then I'll print this value. Okay. So let's run this code and see the result. You can see you're able to see value of x is 100. Now, for example, if I assign the same value to another variable, that will also work. For example, let y is equal to x. Now similarly, I'll print value of y here. So you can see value of y is, y corresponding value will be displayed. So let's run this code. And you can see here, same value of x is assigned into y. So that is why both x and y will hold the same value, which is 100. And the same thing we are displaying here. And this is all done with the help of assignment operator. Okay. Now let me consider an example to perform this assignment operations. Okay. So the task is basically perform swapping. So I'll explain this with the help of a swapping. So let us consider here. Initially, I'll take mutable variables. Why? Because in swapping, I want to go for temporary variable. Okay, that is swapping using temporary variable. So I'll consider all mutable variables here. So one is x and its value is 100, and I'm considering y value as 200. Okay, and also consider temp variable, which is mutable. Okay. So for example, if you want to display here value of x and y initially, so you can display like this: x is equal to, and start writing y is equal to. Okay. So x comma y values we are displaying here. Now perform this swapping. So bring x value into temp, and later bring y value into x, then bring temp value into y. Now again print x and y values. This time I'll clearly specify here before swapping x value and y values. Okay. And similarly, you can see after swapping x value and y value. Okay. So let's run this code and see the result. Okay. So since we are not changing value of temp here, you can in fact take temp as normal variable instead of assigning mute. Okay. So this is what they are saying. Clear? Because we are not changing the temp value later, right? So directly we are assigning temp equal to x. Okay. Only once we are assigning value to temp. Okay. But if you consider variables like x and y, you can observe here x value getting modified here and y value getting modified here. That is why x and y variables must be mutable variables. Since temp is updated, okay, only once, that is basically only one time you are assigning a value to temp. So in that case, the variable need not be mutable. Okay. So that is the reason here. In this video, I'll explain about arithmetic operators in Rust. So starting with addition operation. So you can see here addition operation is represented by plus. Okay, this is a symbol used for addition operation even in Rust. Now let us write a program to perform this operation. First, starting with the main function, and inside the main function I'll consider a sample variables like a is equal to 100 and another variable b is equal to 200. Okay, now I want to perform addition operation between a and b. So for this purpose I'll consider another variable like c. Okay, and directly you can assign c is equal to a plus b here. Okay, and later we can display the result of this addition operation. So if you consider here println of, so we are performing addition operation here. So totally 2 elements, and the result is the third element, right? So you are going to display a comma b comma c here. Okay, so a will be displayed in this position, and then b will be displayed here, and then c will be displayed in this position. Okay, now let's run this code and see the result. So you can see the result as 100 plus 200 is equal to 300. So this is how we can represent addition operation. Now the next operation is subtraction operation. You can see subtraction operation can be represented with the minus symbol. Okay, so for the same program, instead of performing a plus b, you can perform a minus b to see the result of the subtraction, and here also I'll write minus symbol. Now let's run this code and see the result. And you can see 100 minus 200, value will be minus 100. Okay, now let us see here next operation. Okay, so I'll use the next operation, which is multiplication operation in arithmetic operators. So the operator used for multiplication is star. Okay, so here instead of writing minus symbol, I'll use star, a star b, since it is also a binary operator. Okay, so a into b, the result will be stored in c, and we are trying to display a, b, c values. So let's run this code and see the result. And you can see the result is 20,000. 100 into 200 is 20,000, right? Next, coming to the fourth operator, division operation. Okay, so this time I'll perform division operation between b and a, like b divided by a. Okay, and slightly I'll modify here. Instead of writing a comma b comma c, this is going to be b comma a comma c, because I am performing b divided by a. Okay, so if that is the case, let's run this code and see the result. Okay, you can see 200 divided by 100 is equal to 2. Yes or no? 200 divided by 100 equal to 2. So this is how you can get the result here. Okay, now let's consider the other operator, which is remainder operator. Okay, so this remainder operator is represented by percentage symbol. So when you write here b percentage a, okay, so here also you can see b percentage a. So when you're trying to divide 200 with 100, what will be the remainder? So obviously the remainder will be 0. Okay, so that's why you'll get result as 0. So this is how you can perform any operation, okay, that is arithmetic easily here, okay, in Rust. In this video, we'll discuss about examples for compound assignment operators. So first consider a plus equal to b. Here plus equal to is a compound assignment operator. So when you write a plus equal to b, it means a equal to a plus b. Okay. So let us consider a value and b value here. And a value must be mutable. Okay. Why? Because the update is performed on variable a, right? So that's why a must be a mutable value. For example, I'll consider a equal to 100. Okay. And b can be a normal variable. Okay. Consider b value as 400, for example. Now let us perform this compound assignment operation. So here it is a plus equal to b. Now we will print a value and b value. So one is before performing this operation and the other one is after performing this operation. Okay. So before compound assignment, okay, operation, what will be value of a and what will be value of b? So you can directly print like this: a value and the other one is b value. Okay. And here we must display a value and b value. Okay. Now after performing this compound assignment operation, let us display the results. Like after compound assignment operation, what will be value of a and b? Now let's run this code and see the result. So you can see before compound assignment operation, it has printed the original values of a and b, a equal to 100 and b equal to 400. And after performing this operation, which is nothing but a equal to a plus b, right? So when it performs a equal to a plus b, this must be a is equal to a plus b, right? So which is nothing but a is equal to, what is value of a? 100 plus value of b is 400. Now this must be 100 plus 400, 500. So a value gets modified to 500 and there is no change in the b value. So that's why b value should be 400 itself. Okay. Suppose if you are performing the same operation on b by not making b as a mutable variable, then it will throw you an error. So I'll show you. B plus is equal to a. This time you are trying to modify value of b, but you are still keeping b as a normal variable but not a mutable variable. Okay, let's run this code and see the error. See, you can see since we are trying to modify b value, b must be a mutable variable, and since you are not modifying any value of a can be a normal variable. Okay. So which means you have to turn this as a normal variable and turn b as mutable variable. Now when you run this code, you will get the result. Okay. Again you see here, initial value of a is 100, b value is 400. Later you are performing compound assignment operation on b equal to b plus a. So b value will become 500 and there is no change in the a value. Okay. Like this. Now, this is not only the case. For example, if you are trying to perform a minus equal to b, this is nothing but a equal to a minus b. Okay, this is equal to a minus b. So let us perform this operation on here, a minus equal to b. So if you run this code, you will see the result. Okay. Again, the problem here is you have flipped a value. Okay, that is you are trying to modify a value, so a value must be mutable variable, and since you are not modifying b value can be normal variable. Okay, so that's why you can see before performing this compound assignment operation, a value is 100, b value is 400, and after performing this compound assignment operation, a value becomes minus 300 because the operation that is carried out here is clearly a is equal to a minus b, and a value is 100 minus 400, so this must be minus 300, and there is no change in the b value. B value remains same. B value will be 400 itself. Okay, so this is how it will work. Now let us apply the next operation here. So that is multiplication assignment operation. So a star equal to b, which means a equal to a star b. So here I'll apply a star equal to b. So this is going to be a value getting modified. A value becomes a into b, which is nothing but 100 into 400. So the value becomes 40,000. A value gets updated to 40,000, and b value, there is no change in the b value. Okay. And similarly, you can perform other operations as well. Okay, let us suppose this time I'll modify value of a to suppose 400, and value of b also 400. So let us apply division operation, that is division assignment operation. A slash equal to b means a equal to a slash b, that is a equal to a divided by b. So what should be the result here? A equal to 400 divided by 400, value should be 1. Okay, that is a value getting modified to 1, and there is no change in the b value. Okay, and similarly you can also perform a remainder assignment operation. Remainder assignment, that is a percentage equal to b. So now this can be written as a equal to a percentage b. Okay, so here also percentage symbol. Clear? This can be written as a equal to a percentage b. Now let's run this code, and you can see the result. When I write a equal to a percentage b, so this is nothing but a equal to 400 mod 400. Okay, so in this case it is divisible, so obviously the remainder will be 0, hence a value becomes 0, and there is no change in the b value. You can observe here, there is no change in the b value. Okay, so like this you can perform any compound assignment operation in Rust very easily, just like this. In this video we'll discuss about logical AND operation in Rust. So first of all, there are basically three types of logical operators in Rust. One is clearly logical AND operation. So let me write here logical AND operation, and this logical AND operation is represented by two ampersand symbols, and the second operation is logical OR operation, and it is represented by this symbol, and the third one is logical NOT operation, and this NOT operation is represented using this. Okay, now let us clearly explore about logical AND operation in this video. So for this let us consider two variables. Let a is equal to, okay, I'll consider this as a Boolean variable and assign value as true, and similarly I'll consider another variable b and assign this value as false. Okay, now when you want to apply logical AND operation, and you want to store the result in another variable. So for this purpose, I'll take another variable C, and I'm applying logical AND operation between these two variables A and B here. Okay. Now let us print here the result of this logical AND operation. Okay. Now you can observe very first A, okay, applying logical AND with B, and the corresponding result will be C. Okay, so this is A comma B comma C here. Okay, so when A value is true and when B value is false, if you apply logical AND operation, what will be the result? The result will be false. Always remember, whenever you are applying logical AND operation on the operands which are true, then only the result will be true. Okay. So I'll apply all these possibilities here. First, I'm applying here true false combination, and you can see the result as a true logical AND false is equal to false. Okay. And similarly, if I modify here, B value is true. In that case, true logical AND true will be true. See here, true logical AND true will be true. Suppose if I modify A value as false, then false logical AND true will be false. You can see false logical AND true is false. Suppose if I modify B value also to false, then false logical AND false will be evaluated to false. Okay, just like this. So all the four combinations are covered. Always remember, when you are applying logical AND operation, it will result in true if and only if both the operands are true. Okay. In this video, let us explore about logical OR operator. Okay. So for this, I'm taking a couple of Boolean variables. An initial value of A as true. Also consider initial value of B as true. Okay. Now we will apply logical OR operator between A and B and get the result into C. So A logical OR B. So after applying logical OR operator between A and B, the result should be stored in C. Okay. So using println, we can store the result here. Logical OR A comma B comma C. Okay. Now look at this logical OR operator between A and B. And you can see true logical OR true equal to true. Okay. So whenever you apply logical OR operator, you will get false only when both are false. In all other cases, you will get true. Okay. See, if I modify B value here to false, and if you run the code, then you will get true. Okay, because true logical or false is true. And if suppose if I flip this, that is B value is set to true and A value is set to false. In that case, false logical OR true will be again true. Okay. Suppose if I modify B value to false, then false logical OR false will be evaluated to false. So you can see here, false logical OR false is equal to false. Okay. So if you understand four different possibilities here, there is only one possibility that will give you false as result, that is When both the operands are false, then only you will get result as false in logical OR operator. In all the remaining three cases, you will get result as true. Logical NOT operator is different from the other two operators because logical OR, logical AND are binary operators, whereas logical NOT is a unary operator. So which means you can apply logical NOT on a single operand only. So let's take an example here. Let A is equal to true. Okay. Now I am applying NOT operation, logical NOT operation on variable. Okay. A. So let us consider result equal to logical NOT operation applied on A. And let us display the result here. Okay. So result is RES we are displaying here. Okay. So let's run this code and see the result. So whenever you are giving input as true and applying NOT operation on true, so not true will be false. And similarly, if you are applying not false, okay, that is A value is set to false, and here applying not false, that will give you the result as true. So let's run and see the result. You can see result is true because the input A value is false. When you are applying not operation on false, it will be true. The same will be stored in RES, and then we are displaying RES value here. Okay. In this video, we'll discuss about typecasting in Rust. So usually when we want to convert a variable from one data type to another data type, we apply a concept of typecasting. So let's see an example in Rust here. So we use this keyword called as. Okay, as is the keyword which is used to perform typecasting in Rust. And in this example, you can observe decimal as U16. So this expression will convert F64 floating point type to U16 integer type. Okay. Now consider this example, the type conversion from character to integer data type in Rust. So the character data type is internally stored as a Unicode scalar value, and it is nothing but a numeric representation of a character. So the Unicode value of the character capital A is 65. So we get the output of 65 when we are converting the character A into an integer value. Okay. So that's why character A is converted into integer. So we will get its corresponding Unicode value, which is 65. In this video, we'll discuss about Boolean expression. First, what is meant by a Boolean expression? Any expression that returns either true or false as output is considered as a Boolean expression. So remember, any expression that can return either true or false as output is said to be a Boolean expression. Now let us consider an example for a Boolean expression in Rust. So first I'll consider a variable. Let x is equal to 7 be the variable. Now let us write a condition here. So let condition is equal to x greater than 5 semicolon. So this represents it is a Boolean expression. Okay, so you can observe clearly this is going to be a variable declaration and this is a Boolean expression. So in this Boolean expression, when you substitute x value here, what is value of x here? 7. So this is going to be 7 greater than 5. So this condition is going to be true. So when you try to print this value, it should result in true. Why? Because x greater than 5, for this value of x 7 greater than 5 is going to be true. Now this true will be stored in condition. So when you display this using println macro, you will get result as true. Okay. Now let us consider how we can write if statement in Rust. So let me write the syntax for the if statement here. So the general format or syntax of writing if statement will be just like this. First you have to specify if, followed by condition. So this is condition, and then start of block, and here you have to start writing the code inside this block, and this is the end of block. Okay. And if this condition is evaluated to true, the code inside this if block will be executed. Suppose if this condition is evaluated to false, then the code inside of this if block will not be executed. So let me give you an example for this here. So first consider a sample variable here. Let x is equal to 10. Now we can write if condition if x greater than 0. Then we can write code here inside this block and then end of this block. Okay. Now let's see how this is going to be evaluated. Initially you can observe value of x is 10, right? So it will execute this conditional expression, that is 10 greater than 0, and this condition will be evaluated to true. Since it is evaluated to true, this block of statements will be executed. That is, code inside this block will be executed. Okay. Now let us consider another example here. For example, if you consider value of x is equal to -2. Okay. And look at this if condition x greater than 0, and this is a code inside this if block. Now the moment it executes x greater than 0, you can see value of x is clearly -2, so -2 greater than 0 condition will be evaluated to false. So this block will not be executed and the control comes out of this block. Okay. So this is how it will work. Now let me quickly write a program in Rust as an example to this if statement. So first you have to write the function name, that is main function. So we are writing a main function here, and inside this main function I am taking a variable x and its value is 10. Now look at this if condition. If x greater than 0, then inside this block we can write println macro to display here. Okay. So whatever number, okay, is positive, you can write like this. And here we can write x value. Okay. And after this if block, I'm writing a println statement. Okay. To just indicate end of program. End of program. Now let's see how this is going to be executed. So program execution starts from the main function, and the initial value of x is 10. So this will create a variable x and its value is 10. And it will check this conditional expression. 10 greater than 0 condition will be evaluated to true. Since this condition is evaluated to true, it will immediately display this println statement. Okay, that is whatever content we have written inside this println macro will be displayed. So what is value of x here? 10. So the output will be, okay, it will display simply 10 is positive. Okay, it will display 10 is positive. And after displaying this statement, now control comes out of this if block and it will start executing this println statement. And here it will display end of program. It will display end of program. Okay, just like this. Okay. In this video, we'll see how if-else statement is going to work in Rust. So first understand the general format or syntax of writing a if-else statement here. Okay. So you have to specify if followed by condition, and then here this is going to be code. Okay, and after this similarly you can see here else block, and this is also code inside the else block. Okay, now let's see how this is going to work. Whatever condition that you are writing here, if this condition is evaluated to true, in that case whatever code is written inside this if block will be executed and else block will be simply skipped. Suppose if this condition is evaluated to false, in that case code inside this if block will be skipped and the code inside this else block will be executed. So that is how it is going to work. Okay. Now let us consider an example for this if-else statement. Okay. So let us suppose I am considering the main function, and inside the main function we will take a variable like x is equal to -2. Okay, and here I am writing a if-else block if x greater than 0. Okay, so you can write like this print ln whatever number is greater than 0. Okay, so you can write that x value here, and this is my if block. So after the if block you have to write the else block. So inside the else block we can write like this print ln. So number is less than or equal to 0. Okay, I'm writing number is less than or equal to 0. Okay, and this is going to be end of this particular function. Okay, now let's see how this is going to work. First, the program execution starts from the main function, and x equal to -2 will create a variable x and its value is going to be -2. Now inside this -2 greater than 0 condition becomes true or false. So this condition will be evaluated to false. So it will move to the else block,
and inside the else block this statement will be executed, and you can see obvious output will be here. This will display the statement saying whatever value that is represented inside this particular value x. Okay, so minus 2 is less than or equal to 0 because the x value will be displayed here. Okay, so the obvious output will be minus 2 is less than or equal to 0. Okay, so this is how it will work.
Now, in this video, we'll write a sample program to check whether the given number is even or odd. Okay, so given number is even or odd. Now, for this, we start with the main function, and inside this main function, let us consider a variable and its value as 8, for example. Now we will check this condition of value of x is even or not by dividing it with 2, and you will get a reminder whether that reminder is equal to 0 or not. Okay, so if suppose this reminder is 0, it means whatever number that you are taking is divisible by 2. In that case, we can display it is clearly a even number. So you just need to display even number. Okay, now suppose if this condition is evaluated to false, then we can display odd number. Any number which is not even will be an odd number. Okay, so just like this. Okay, now let us run this code and see the result. So you can see it is clearly displaying the given number is even number. Suppose if I modify this number to 7, for example, in that case it will display odd number, isn't it? Okay, so this is how it is going to work. So in this video, we'll discuss about if else condition, or you can also call it as else if ladder. So consider this one. If else if expression. Okay, so if you look at the general syntax of writing this statement, okay, remember this is a multi-way selection statement where you can write multiple conditions. Okay, so the general syntax will be just like this. If condition 1, okay, first we have to specify condition 1 and then corresponding code block. So this is code block 1, and here else if condition 2, and this is going to be code block number 2, and finally this is else. Okay, and it is representing code block number 3. Okay, so let's see how this is going to work. First, if this condition 1 is evaluated to true, in that case code block 1 is executed. So once the code block 1 is executed, then the control will be moved right here by skipping code block 2 and code block 3. For example, if this condition 1 is evaluated to false, in that case control is moved to evaluate condition 2. If this is evaluated to true, then it will execute code block number 2. So once the code block 2 is executed, then code block 1 and code block 3 will be skipped. Okay, Suppose if this condition 1 is evaluated to false and condition 2 is also evaluated to false, then control comes directly to code block 3 for execution. Okay. Now let me explain with an example here. So I'll consider a variable, let x is equal to 2. Okay. If x greater than 0, now this is going to be code block here. Similarly, else if x less than 0, then this is the code block. And finally, else block. Okay, this is the code block. Okay. Now look at this, value of x is clearly 2. So 2 greater than 0, condition becomes true and this code block will be executed. Suppose if you are considering x equal to -2, in that case -2 greater than 0, condition will become false, whereas -2 less than 0, condition becomes true and this code block will be executed in that case. Okay. So for example, if you are taking a variable like x is equal to 0, in that case this if block will be false. Okay, that is whatever condition here is 0 greater than 0 becomes false, and coming to the next condition 0 less than 0, condition becomes false, and finally it will move to the else block and it will execute this code. Okay. In this video we'll write a program which will check whether the given number is positive or negative or 0. So this is the program to find given number is positive or negative or 0. Okay. So to check whether this number is positive or negative or 0, we can make use of else if ladder. Okay. So where you can write multiple conditions, right? Okay. Because this is a multi-way selection statement. Okay. So first let me start with main function, and inside this main function we'll consider a sample variable like let x equal to -2. Okay. Now we will check by writing a if condition here. If x is greater than 0, then we can print or display this is a positive number. Okay. So I'll write println. Okay. Is positive. Okay. So you have to represent x here just like this. Now here we can write else if x less than 0, else if x less than 0. So in that case we can display negative. Okay. Because value is basically less than 0. Okay. And finally in the else block we can display is 0. Okay. That particular number is 0. Okay. Just like this. Now let's run this code and see the result. Yeah. So now you can check here. So -2 is negative, isn't it? So let's run this. -2 is negative. Okay. Why? Because first it will check here -2 greater than 0, condition will become false. So it will move to this block and checks the condition minus 2 less than 0, condition becomes true, and immediately it will display minus 2 is negative. For example, if I modify this x value to 8 and run this code again, this time you will see 8 is positive. Because 8 greater than 0, condition will become true, and immediately it will display 8 is positive. Okay, just like this. Suppose if I give input as 0, in that case 0 greater than 0 condition becomes false, 0 less than 0 condition becomes false, and finally it will go to the else block and it says 0. Okay, so you can see it will display like this. Clear? In this video, we'll implement how to find maximum value between two given numbers with the help of if-else statement. So for this, inside the main function, let us first consider a couple of variables. For example, let x is equal to 100. Also, let y is equal to 200. And consider one more variable, max variable, so that you can basically find maximum value and store it inside max. Okay. So after declaring these variables, now using if-else statement, suppose if x is greater than y, my idea is to store this maximum value as x, max is equal to x, because x is already greater than y. Suppose if this condition is evaluated to false, then inside this else block, you can make max is equal to y. So you can observe here, if x is greater than y, then max is equal to x. If x is not greater than y, it means in the else block, max is equal to y. So finally, we got the maximum value inside a variable called max. So let us print here maximum value. Okay, like this. Now let's run this code and see the result. Yeah, so we should not place this inside the brackets. So directly write if x greater than y. Yeah, x is greater than y, condition becomes false because 100 greater than 200 condition becomes false. So it will move to the else block and it will execute max is equal to 200, and then we are printing the maximum value as 200. You can see the result, maximum value is 200. Okay. Now similarly, we can also find maximum among three given numbers. Okay, maximum inside three given numbers. So for this, we have to basically consider three values. Let us suppose let z is equal to 150, for example. Now among three values, I am going to find the maximum value. So in this case, first write down the if condition. If x greater than y, logical and x greater than z. So in this case, you can note down max is equal to x. Suppose if this condition is false, then you can write an else if condition here. So it should be y greater than x and y greater than z. If y is greater than x and greater than z, in that case, you can write max is equal to y. Finally, inside the else block, okay, so if x is not maximum, if y is not maximum, then all you need to do is max is equal to z. Okay, and finally, we have to display the maximum value, isn't it? So let's run this code and see the result. Okay, so this is logical and okay, yeah. So you can see maximum value is 200. Clear? So initially it will check x greater than y, logical and x greater than z. 100 greater than 200, logical and 100 greater than 150, condition will become false. And here 200 greater than 100, logical and 200 greater than 150. So both these conditions are true, therefore max is equal to 200, and later we are displaying the maximum value as max. Okay. So this is how we can find maximum among three given numbers using LC ladder. Okay. Now let us discuss about concept of loops in Rust programming. So first, what is meant by loop? A loop is nothing but whenever you want to execute a block of code for multiple times, you can move to the concept of loop. Okay. So for example, I want to just print hello for 100 times. Then you can write this statement which can print hello inside a block and run that block for 100 times. Okay. So in Rust programming, how many ways you can make use of looping? Okay. So there are totally three ways. One is using loop expression. Second one is using while loop. Third one is using for loop. Okay. So totally there are three ways to achieve the same. Okay. Now let's see how this loop expression can be written. Clear? So look at this loop expression. The general syntax of the loop expression will be, you can write loop, okay, and inside this loop you can write code which is used to execute. Okay. So this is the syntax of the loop expression. Okay. Now inside this loop you have to write proper condition to terminate this loop. Okay. Otherwise it will enter into an infinite loop. If you are not writing a condition properly, then it can lead to an infinite loop. So let me show you an example here. Suppose I'm taking a main function here, and inside this main function we are writing a loop, and here the println macro in order to display hello. Okay. Now inside this loop there is no condition for termination, isn't it? So if you write like this, then hello will be displayed for infinite number of times. That is, it will lead to an infinite loop. Okay. So which means in the output you will see like this: hello, hello, and so on, hello, and so on, like this. Okay. Now you just need to add proper conditions in order to terminate the loop. Okay. So let us see how we can actually write condition in order to terminate the loop. Okay. So for that you just need to write break statement when a condition is met. Okay. So I'll show you here. For example, I want to display hello for 10 times. I want to display hello for 10 times. So in such case, how we can write this loop? Display hello 10 times. Okay. So first consider main function. And inside this main function, let us consider a variable, a mutable variable n, and its value is initially 0. Now loop these statements. So inside this loop, we can perform n equal to n plus 1, and later I will display hello here using println macro. And now here comes the condition. So look at this condition carefully. If okay, n greater than or equal to 10, if n greater than or equal to 10, in that case I'm asking you to break the loop. Okay, suppose if I like this, okay, so if I write like this, in that case let's see how this is going to work here. So program execution starts from the main function, and inside the main function you are taking a mutable variable n, and its value is initially 0. Now inside this loop you are writing n equal to n plus 1. So n value becomes 0 plus 1, it will be 1, and immediately it will display hello in the output screen. So you can see in the output this will display hello. And after displaying hello, look at this conditional expression, n greater than or equal to 10. So this must be 1 greater than or equal to 10. Condition will become false. So associated block will not be executed. It will move to the next iteration. In the next iteration, you can see n equal to n plus 1. N equal to 1 plus 1 value will become 2. And again hello will be displayed here. And later n greater than or equal to 10. This time 2 greater than or equal to 10. Condition will become false. So break statement will not be executed. Okay. In the next iteration, n equal to n plus 1, value becomes 2 plus 1, which is 3. And again hello will be displayed. Okay. And then 3 greater than or equal to 10. Condition will become false. And so on like this. So totally 10 times it will work, isn't it? The same hello will be displayed for 10 times. Why? Because this n value, the moment n value becomes 10, okay, after displaying 10th time hello, then 10 greater than or equal to 10, condition becomes true and break statement will be executed. It will move the control out of the loop. Okay. So this is how it will terminate the loop, by writing a condition and the associated block inside that condition is break statement. Okay, just like this. In this video we'll discuss about concept of while loop in Rust. So generally we write while loop in order to execute block of statements until the condition becomes false. So let us see the syntax of writing a while loop. So here we can write while condition, and inside this we can write code block. Now whatever statements that you write here comes under code block outside the while loop. Okay, so this is not going to be part of while loop. So let's see how this is going to work. First of all, while condition, this condition will be evaluated. If this condition is evaluated to true, then this block of statements will be executed. And again, after executing this code block, again the control is transferred to execute this condition. If it is again true, then the block of statements will be executed again. And this is continued until the conditional expression becomes false. Okay. So once the condition becomes false, control will come outside of the while loop. Okay. So which is known as termination of the loop. Clear? So now let us write an example using while loop. Suppose if I want to display numbers starting from 1 to 5, let us suppose I want to display these numbers from 1 to 5. Okay, so we can write or start with the main function. Okay, function main, and inside this main function let us consider a mutable variable. Consider name of the variable is counter, and its value is initialized to 1. And let us consider the condition as while counter less than 6. So when this condition is true, then we are going to display the counter value. So like using println macro, we can display this value of the counter. And after this, I'll update the counter value. So which is counter plus equal to 1. And you can see here how this is going to work. First of all, you can observe initial value of the counter is equal to 1, isn't it? Counter value is initially 1, and it is a mutable variable. So first it will check this condition. So what is this condition? Counter less than 6, which means 1 less than 6 condition becomes true. Now the block of statements will be executed. When these block of statements are executed, first it is going to print counter value. So in the output it will display counter value 1. After that, counter equal to counter plus 1, which means value of the counter becomes 2 right now. And in the next iteration, 2 less than 6. Again the condition is true. Now it will print the counter value, which is 2. And later counter plus equal to 1. This time counter value will become 3. 3 less than 6. Again condition becomes true, and it will display the counter value as 3. And later counter plus equal to 1, which is again counter value gets updated to 4. 4 less than 6 condition becomes true, and again counter value, which is 4, will be displayed. Later in the next iteration, counter value becomes 5. 5 less than 6 condition becomes true, and it will display the counter value, which is 5. Okay, so this is how you can observe the output will be displayed starting from 1, 2, 3, 4, 5. Okay, just like this. Now here consider an example. If you are not writing counter plus equal to 1, okay, let us suppose you consider another example. In that example, suppose you missed writing this particular statement. Okay, if that is the case, then what will be the output? You can see in such case counter value 1, 1 less than 6 condition true, and it will display counter value as 1. Okay, and in the next iteration, value of counter is not getting updated. So again it will check the conditional expression as 1 less than 6. Again condition is true. It will display the counter value as 1, and so on like this. Okay, so this is how it can enter into an infinite loop. So we have to write carefully where it contains the conditional expression and also the update statement, so that it will modify the value of the loop variable to the next iteration. Okay. In this video, we'll implement a loop in order to display numbers from 1 to n. Okay. So let us suppose I'll go for while loop in order to display numbers from 1 to n. So let us suppose initially I'll consider n is equal to 10. Okay. And now consider a variable, okay, which is a mutable variable, okay, and its value is initially 1. Okay. Now I'll iterate this variable so that it will reach up to n, and every time it will display I value. Okay. Since this is a mutable variable, we can actually change value of I, right? Okay. So for this, let us write a while loop here. While, okay, I is less than n. Okay. So if this condition is true, I less than n, then I'll print value of I. Okay. So which is like this. And after that, we need to increment value of I. Okay. So here we can go for a compound arithmetic assignment operation to increment value of I by 1. Okay. And this will be able to print all the numbers starting from 1 to 9. Okay. So to print 10 also you have to write like this: I less than or equal to n, so that n will also be printed. So let's run this code and see the result. You can see all the numbers starting from 1 to 10 are clearly displayed, isn't it? Okay, just like this. Now in this video we'll find the factorial of a number using while loop. Okay, so to find the factorial of a number like n, for example, n is representing a number like 5, for example. Now I want to find out this 5 factorial. So in order to iterate, I'll take a loop variable like I, which is a mutable variable. So initially I value will be 1, and similarly I'll take another mutable variable to store the result, because my idea is to extract numbers from 1 to 5, and every time I multiply the result with these numbers. Okay. So consider f is equal to 1 initially. Now let's write while loop. So while I is less than or equal to n. Okay. While I is less than or equal to n, in that case we can print here, that is basically we are going to compute factorial and later we will print. So I'll go for f equal to f into I operation, and later I value should be incremented by 1. So this must be I plus is equal to 1. And once the factorial computation is over, then we can display the result that is stored inside variable f. Okay. So here we can write println factorial result is f. Okay, just like this. Now you can see n equal to 5, we are computing 5 factorial, the result is 120, isn't it? So you can observe here, in every iteration we are multiplying f with I, where I is iterated starting from 1 to 5 because n equal to 5 here. Okay, to update we are performing I equal to I plus 1 here, and finally the result is like this. Okay, now let us consider how to work with for loop in Rust programming. So let us see the general syntax of the for loop. So before going into the syntax, for loop is mainly used to basically iterate over range of numbers. So use it to iterate a range of numbers. So in this range of numbers, we have to specify basically what is the start value and end value. And remember, while writing this for loop, the start value is inclusive, whereas the end value is clearly exclusive. Okay. So now let us consider the corresponding syntax here. First, for, and here variable, for variable in, specify the start value in the range and followed by two dots. Now specify the end value. Okay, and remember, start is inclusive, end is exclusive. Okay, and here we have to specify the code block or block of statements inside it. Okay, so immediately this for loop is going to iterate starting from this value up to less than this end value, and every time it will execute this block of statements clearly. Okay, now let us consider an example. Similarly, to display numbers starting from 1 to 5. Okay, so basically I want output like this. I'll show you here. The expected output must be like this: 1, 2, 3, 4, 5. This is the expected output. So to get output like this, in Rust we have to write a program using for loop by specifying for loop inside the main function, for example. So I'll take a loop variable here for I in. So let us write the range here, start value and end value. Since end value is exclusive, we have to write like this. And inside this for loop, we can include this print statement. Okay. To display I value. Clear? Now look at this range of numbers starting from 1. So this will generate range of numbers 1, 2, 3, 4, 5. 6 will not be generated because it is exclusive. Okay, so up to less than 6 will be generated starting from 1, and we are displaying those I values here. Okay, so that is why we are able to produce an output like this: 1, 2, 3, 4, 5. Okay, now let us use for loop in order to find the sum of numbers up to n. Okay, so for this, first consider n value. Let us suppose n is equal to 5. Okay, so we want to perform sum of numbers starting from 1 up to n. Okay, so for this I'll take s is equal to 0. Since we are going to update this s value, we have to consider it as a mutable variable. Okay, and also in order to iterate in each loop iteration, we require a mutable loop variable okay, like this. Or since you're writing a for loop, you don't even need this type of variable, okay, so you can directly write for I in, okay, so it starts from 1 and iterates up to n, yes or no? So since if you're writing for loop, this will be a lower bound number or start value, and this is the upper bound number or end value. And remember, this end value is exclusive, whereas start value is inclusive. So for this purpose, you have to include up to n plus 1. Okay. Now, in each iteration, we are going to add this I value to s. So this should be s equal to s plus I. Okay, s equal to s plus I. Now, when you come outside this for loop, you can start printing s value. Okay, so this must be like this. Sum is s value. Okay, just like this. So let's run this code and see the result. You can see sum is 15. Why? Because this loop is going to iterate starting from 1 to 5. So this will be doing s equal to 1 plus 2 plus 3 plus 4 plus 5. Okay. So in the first iteration it will add 1, in the second iteration it will add 2, and so on. In the fifth iteration it will add 5. So this should be giving result as 15. Okay, sum is going to be 15, and the same result is printed here. Now we'll discuss what is meant by an array. So how can we define this array? Array can be defined as list of elements which are of same data type. Okay, so this is collection of a list of elements which are of the same data type. Okay, now for example, if we want to store the first 5 natural numbers, then we can create an array instead of creating 5 different variables. So let us see this example here. We can write let arr, which is name of the array, and these are the array of first 5 natural numbers followed by semicolon. So in this case we have created simply an array of 5 natural numbers. Okay, now let us see in how many ways we can create an array. Okay, so creating array, this can be done in 3 different ways in Rust. First way is array with same data type. Array with data type. Okay, and the second type is array without mentioning data type. So we can write it as array without data type. And the third type is array with default values. Array with default values. Okay, so these are the 3 different ways in which we can create an array. So let us understand each of these array creation methods in detail. So starting with the very first one, that is array with data type. So array with data type. So in this case, whenever you want to initialize an array, you have to specify the data type. Okay, you have to specify clearly the data type. So let us see how we can declare with an example here. Let name of the array is numbers. Okay, and here we are specifying the data type of the array as I32 semicolon 5 is equal to list of elements 1, 2, 3, 4, 5. So let us see what is meant by this statement. So you know this numbers is clearly representing the array name. It is representing array name, and followed by I32 here. Okay, so you can see I32 is representing the predefined data type, which we have already discussed. Okay, and all these array elements are of this particular data type, integer data type, which is occupying 32 bits. And next, 5 is representing the size of the array, size of array, and this is indicating elements inside the array. This is indicating elements inside array. Okay, so this is how you can understand or declare array with data type. Now for this, when I declare like this, how this is going to be stored. For example, okay, to store all these elements, numbers is the corresponding array name, and all these elements are stored one after the other sequentially. In the first location it will store 1, in the second location 2, third location 3, fourth location 4, and fifth location 5. So you can observe these are the indices. Okay, this is index 0, index 1, index 2, this is index 3, and this is index number 4. Okay, so internally it will be stored like this. Okay, suppose if you want to display this particular array, okay, so then it's easy to display this content. Just simply write println macro and use this array name. Okay, so let me write here, for displaying this array. Okay, to display this particular array, so you can simply write like this, print ln of name of the array, so followed by semicolon. So this statement will display all the elements of the array. Okay, so this is how it will work. Now let us move to the second type of representing array. So the second type is clearly array without data type. Array without data type. So in Rust, we can also define array elements without specifying the data type. So let us see this type of representation. So inside the main function itself, you can directly write list of numbers like this. Let numbers is the name of the array is equal to the list of elements like this: 1, 2, 3, 4, 5. These are all list of elements. Okay. Now to display these elements, simply you can write print ln numbers. Okay. So it will automatically display the output like this. You can see numbers array will be displayed containing elements 1, 2, 3, 4, 5. Okay. Now clearly, if you observe this example, numbers is representing the name of the array, and these are all elements which are stored inside this array. And you can see here we have not defined the data type and the size of the array. So in this case, Rust compiler will automatically identify the data type and size by just looking at these array elements. Okay. So this is how you can also make use of array declaration without specifying the data type. Okay. Now let's see another method of working with array. So the third method is array with default values. So you can also specify some default values inside the array. So let me consider an example here. Let numbers representing the name of the array, and here I'm specifying like this: I32 semicolon 5 equal to, here the list of elements or array of elements I'm writing like this: 3 semicolon 5. Okay. So this is representing initialization of array with default values. Now for this code snippet, if you try to print using println macro numbers, so what should be the output here? So if you look at the corresponding output for this particular code, it will be just like this: 3 comma 3 comma 3 comma 3 comma 3. Why? Because as this is array with default values, here we have created an array here with the help of an expression. Okay. So you can understand the meaning of this expression here. So this is considered as a repeat expression. This is a repeat expression, and according to this repeat expression, it says that 3 should be repeated 5 times. Okay, it means it is going to fill the entire array with 3's, and that will be repeated 5 times. Okay, so it will store the array of elements like this. In all the 5 locations, it will keep value as 3, just like this. Okay. And even in the previous example, you can make use of this. Okay. You can have the combination of the previous example. Okay. So here also, in fact, you can apply this logic. Okay. For example, in this, we are trying to use array with default values. Okay. Here also you can write like this. Now this becomes example for both array without data type as well as array with default values. Okay. Again, the output is same. All threes will be displayed. It means 3 will be repeated for 5 times. Okay. So by default, whenever you write an array, just by specifying let array name like numbers is equal to 1, 2, 3, 4, 5. It represents this numbers array is clearly immutable. Okay, it holds the property of immutable. So which means when you try to modify the value of this particular array, okay, any element of this array, if you are trying to modify, then it is going to produce an error. Okay, why? Because by default they are immutable. But you can also define a mutable array in Rust. So let's see how you can define mutable array. So first, mutable array representation in Rust. So let specify mute keyword, then followed by name of the array, and let us suppose if you are specifying the data type also, in that case you can write followed by number of elements that you are going to store inside this array is equal to. Now these are the list of elements or array of elements that we are going to store here. Okay, so now at this moment when you print this particular array called numbers, you will see the elements 1, 2, 3, 4, 5. But we can also change any element or in fact all elements of this array. So let's see an example here where I will try to change the element located at index number 2. So I'll make it as 0. And later I'm trying to print the content of this array called numbers. Okay, so this is the code snippet, and you just need to include this code inside the main function. That's it. So write this code inside the main function. Okay, and see the magic. You will see there is a change in the array of elements because we are modifying value located at index 2 and setting it to 0. So look at this. Initially when you are executing, okay, so up to here the array created will be just like this. It will have totally 5 contiguous locations, and in each of this location it is going to store values like this 1, 2, 3, 4, 5, and this is numbers array. And if you look at the indices, this is index 0, index 1, this is index 2, this is index 3, this is index 4. Okay, now in the next step, that means here we are trying to modify value located at index number 2 and set it as 0. So here this value which is located at index number 2 now will become 0. Okay, so that is why when you print this numbers list or array, okay, so it will display the output like this 1, 2, 0, 4, 5 will be displayed. Okay, so this is how whenever you want to make array mutable, make use of the keyword mute to define array, and later you can modify a specific index corresponding element, or in fact multiple elements, okay, you can update or modify since it is mutable array. So most of the time we require to find the length of the array, right? So let us see how do we find length of array in Rust. So in order to compute length of the array, we can make use of alien method. This is alien method which can be applied on the array in order to find the length of that particular array. Okay. So now let us see an example here which can compute length of the array. So this is going to be main function, and inside this main function, so let us take an array. So you can use any type of array. So let us suppose I am using array without data type. So 1, 2, 3, 4, 5. Okay. Now, if you want to display this array corresponding length, you can make use of println statement, which is a macro, to just display the length of the array. Okay. So here I am writing array length, and you can display array corresponding length here. So this is array dot alien. Okay. So this is how we can write here. And this function array dot alien, okay, this alien method is going to compute the length of this array. So how many elements are there? Totally 5 elements are there. So it will return length of the array as 5. So overall you can observe the output will be displaying array length colon 5. Okay. So this is how it will display. Now let's see how you can loop through the array of elements. So let us consider, for example, let A is an array and it contains elements like 1, 2, 3, 4, 5, 6. These are the elements of the array. Okay. Now let us iterate through this particular array with the help of index in for loop. So let's see, for index in, so the index must be starting from 0 index, okay, up to less than 6. So I can write it as 0 to 6. Okay. Now we can display the corresponding elements which are stored in this array. So you can write println. So first I would like to display the index associated with each of the values stored inside the array. Okay. So I'll write index contains value. So I'll display value over here. Now you can see directly accessing index. After that we need to access the value, right? So you just need to specify a of index. Okay. Now when you run this code, you will see the result here. Okay, that is just semicolon. And the result is clearly index 0 contains value 1, index 1 contains value 2, index 2 contains value 3, index 3 contains value 4, like this. All the elements are clearly displayed. isn't it? Now, for example, if you are writing this here or replacing with n value, which is representing the length of the array, that can also be computed here. Let n is equal to a dot len. So this will find the length of the array. So instead of writing 6 here, I can write n now. So I'll run again and the output is same. You can observe. So this is how you can actually compute length of the array in a variable and iterate over. Okay. So not only these elements, in fact, you can also iterate over, okay, some strings that are stored inside this array. Okay. So I'll show you another example here. For example, consider let, okay, days is equal to, so I'm writing different days here, Monday, okay, next one is Tuesday, after that okay, totally I'm writing 4 days. Okay, now we want to iterate through this particular array and display the elements. So for this we can write for, okay, again if you want to compute the length of this array, that can be done here. Let n is equal to days dot len. So this will compute length of the array. Now for index in, okay, 0 to n, we can iterate and start displaying here index and corresponding value. Okay, index and corresponding value. Okay, so otherwise we can write this particular index contains this value, okay, just like earlier we have written, right? So you can see I'm going to use index here, later days of index. Okay, now run this code and see the result. You can see index 0 contains value Monday, index 1 contains value Tuesday, and so on like this. Okay, so this is how we can make use of for loop in order to iterate through the elements of the array.